Lesson 9.7, circles and lengths of segments. So those are segments that are inside or tangent to the circle or secants going through the circle. We showed that intersecting chords create similar triangles. Since we have similar triangles, we can set up ratios and cross multiply. So that's where all of these theorems come from. I'm not going to prove them, but you'll see the multiplication reminds you of a proportion. So they're very complicated, even though I say that it's easy to remember, easy to execute. I'm lying. They're tricky. So here's the first one, which is the easiest of them. And it just says you have two chords that crisscross. And I'm not trying to make these in any way, shape, or form to scale. So you have a 2 here, 3 here, 10 here, and an X here. Then, if you read this, it says the product of the segments equals the products of the segments. 2 times X equals 3 times 10. X equals 15. Again, because they are similar triangles, you can write them that way. A more complicated type problem will look like this. Notice I'm not even drawing the center to my circle. I don't want people to make any assumptions. This is our chance to give you some algebra practice. So you would multiply the pieces of one times the pieces of the other. And since we have a second degree polynomial, we need to factor it, or set it equal to 0, I should say first. And you get a kind of elegant solution. You get 6 and 2, which if you look at it, 8 minus 6 equals 2. You'd either have 2 here or 6 here, or the other way around. 8 minus 2 is 6 here and 2 here. So it's kind of neat that the math accounts for the fact that you don't know where the x is going to go. So those are two types of problems where they're inside. Now I've got secants. This gets complicated. Finally drawing myself a decent circle. And this is the one that I always mess up. This is the one I find people make mistakes on the most. So it's the outer piece, 4, times the whole piece, 8 plus 4. Outer piece 6, the whole piece x plus 6. This is 4 times 12, 6x plus 36. Gives me 12 equals 6x. So 6 times 8 is 48. 4 times 12 is 48. That works. That one does not feel intuitive to me. It feels very forced, so you need to work on that and know what you're doing. It's tricky. And the last one, very similar to the one we just did. You've got a secant and a tangent. We'll call this x, we'll call this 18, we'll call this 2. This part is the same as what you just saw. 2 times 2 plus 18. And a lot of people jump on this and just go, hold it. No, that's right. Except I want to make this 16. Better. So 2 times 16 plus 2. And as I was starting to say, a lot of people want to just go 2 times 18. I really recommend writing it out that way so you don't forget what you're doing. 2 times 18 equals x squared, 36, x squared, x equals 6. So 2 times 18 is 36, 6 times 6 is 36. It works. So there's only 3 types of problems here, but they get very complicated. They're hard to keep straight. Practice makes perfect. Good luck.